Good morning and welcome to all the participants. Myself, Architect Rajiv Sharma from APJ Institute of Technology, School of Architecture and Planning, Greater Noida, brings you uh, to this lecture by architect Sanah Mengi, who works at Architects, New York. She will deliver a talk over the climate responsive design and passive architecture. Architect Sanah Mengi is a licensed architect in India, and she graduated from Columbia University in program Urban Design. Since graduating with her master degree, she has been working as an architectural designer in architect. Her undergraduate degree in architecture from Gateway College of Architecture and Design persuaded her to explore her interest in the field of architecture, construction, and design. Her career path has made her wear multiple hats in her career, from a business owner, project architect, architectural designer, urban designer, and an educator. Her experience and interests stem very strongly towards sustainability and what climate responsive means. From her undergraduate degree to her full-time role in architect, she has become an advocate of sustainability in design. There is never enough to learn about sustainability. With that belief, she has been talking about the topic and currently is working on multiple lead projects. We welcome you, Sanah, at, for this lecture, and it's over to you. Soon, our director, sir, will also join.
Thank you, Rajiv sir, for giving me this opportunity to come here and share about my something that I'm extremely passionate about in sustainability, and have been doing it since my second year of undergraduate school. And I think it's a great moment for me specifically here because we have Anurag Roy in the participants, and he's someone who has who first introduced me to this topic, and because of that, it has made me very passionate about that. And I have continued this interest throughout my dissertation, thesis, after my undergraduate degree, and also continuing it in other terms of resilience and social resilience during my at an urban scale, and now trying to do it professionally as well. So thank you for giving me this opportunity to share what my knowledge is on this topic with everyone. And if you allow me, I can start my presentation.
Yeah, please, Sanah, over to you.
Please let me know if you can see my slideshow.
Yeah, it is visible.
Okay. So as sir very clearly introduced me about what I'm doing right now, I'm a recent graduate from my master's program at Columbia University in New York in the urban design program. And I am currently working as an architectural designer at Ennead Architects. Beside working at Ennead Architects, I'm also trying, at Ennead, I'm working for multiple sustainability projects alongside core architecture projects, but also trying to pursue my different licenses in LEED, in WELL, and in Passive House. That is something that I'll be talking about throughout this presentation, to talk to all the emerging professionals and students right now, how you can take forward sustainability. And before I start this presentation, I would like to share that what are the agendas for this presentation. So we're going to have some definitions about what sustainability is, because sustainability is such a huge word and there are so many buzzwords that get related to sustainability. So where one stands when it comes to sustainability, and what is the core designation that we'll be discussing in our presentation today. Something a little about climate and Copen climate, because I feel that that is a very important part that comes with sustainability or climate responsive architecture. Vernacular architecture, passive and heating, cooling and heating techniques, how it works in different countries around the world. And I am trying to bring in a few global case studies along with India and abroad of how other countries and India is doing passive architecture and climate responsive architecture. And then another interesting thing that we're going to talk about here is also passive house. That is very different. And then with case studies and takeaways, we will take any questions. So when you talk about sustainability, there are a lot of buzzwords as students, as professionals that we hear. That's green architecture, net zero buildings, sustainable architecture, climate responsive architecture, bioclimatic design, passive architecture. But there's so many things that one has to focus on in sustainability when you think about it. And then there's more things. There's more things like ecosystems. There's energy, how's the energy performance? There's carbon, that is the biggest, most important thing that people talk about, embodied carbon, carbon dioxide, chlorofluorocarbons. And then there's equitable communities, there's resources, economy, how's the money working, wellness, comfort conditions. And then there's also human beings. How is there human comfort? Is there how are people liking the space? And even on top of all that comes LEED. That is, there are certifications that one can do. There is GRIHA, there is IGBC, there is a living building challenge. Well, what are all these terms? What is sustainability? In the depth of all the terminologies that we have here, one can usually get lost. And then there is a Venn diagram that talks about sustainability being three pillars, that is social sustainability, environmental sustainability, and economic sustainability. As architects, we stand in the middle of this circle, that is sustainability, and we are always pulled together from money, from energy, from the environment, climate, from the society, how people are going to be affected by it, and it all ends up pulling us in different directions wherever we want to go. And as architects, we can continuously feel lost. However, in this presentation, we are trying to make sure that we start small. We understand our ancestors, we understand our old ways of doing things and what is happening now. So for the course of this presentation, we are going to be sticking to climate responsive architecture, bioclimatic architecture, and passive architecture for the first, understanding these three and how they are related to each other. And if possible, in the near future, we can start talking about more other things like green architecture, sustainable architecture, and net zero energy buildings. So when you talk about climate responsive architecture and bioclimatic design, they are both linked to each other. Bioclimatic design is also a way of designing buildings according to the local climate. And climate responsive architecture is when you design in a local climate using bioclimatic design techniques that responds to the area, to the microclimate where a building was created. And both of these are interlinked with each other. And then when these two parts of design collide with passive design, that is to make comfort condition using passive techniques without using energy, providing heating or cooling without energy, is called as passive architecture. Together, these three develop a building, develop an architecture that becomes a part of not only providing comfort conditions, but moves toward it's a sustainability that is environmental, that is also towards the social. And then the third factor is the design that can make it into the economic sustainability as well. So as students, it's also very important for us to understand the Köppen-Geiger climate classification that talks about different types of climate zones, different places, and each of these places that you see here has a design that is different from each other. So I am from Jammu Kashmir in India, right here. We're going to talk about Hyderabad and Pune as case studies. We're going to have a case study in Singapore that is a completely different space. Then we're going to talk about New York, that's where I am right now. And then also another desert condition in the USA, that's Arizona, which is facing many troubles like a lot of countries and the cities in the world. So this diversity that we are trying to see, and this map specifically tells you that we are going to target five completely different climatic zones, one being a hot and arid, one being a completely cold and a cold and humid environment, one being a desert-like environment, and two of being tropical temperate environments. So as someone who has been inspired by looking at vernacular architecture and how things work in the used to work in the old times when we didn't have air conditioners in hot and arid climates, we start to look back into sustainability techniques that we are going to start to talk about now. So this is a diagram of Iranian wind catchers that used to exist in age-old times. And the wind catchers had a basic phenomenon. They had a wind tower like this one with louvers. Because of the louvers, the wind used to come in with a gush, and cold wind used to accumulate come in these wind towers, and the cold air was captured in the cooled basement that used to create a low pressure zone, and hence cooling in the water that is in the basement below. Because of all this, the cooled water, the current difference moved from positive side to from a positive pressure to a low negative pressure. So that is something that is very important to understand. How does wind flow? A wind flows from a area of high pressure, that is cold wind, to a place of low pressure, that is the warm air. This phenomenon is going to be repeated in a lot of scenarios in the presentation. So that is something that one must understand. And then because of this pressure gradient, that is the high pressure zone to the low pressure zone, all the cold air from the basement, because of the convection and evaporation, goes into the different places, and it is connected throughout the basement, making the complete apartment or the houses in these areas cooled. Then this is a very old Persian technique that is similar to the one that we saw here. It is called as the Sawan Bhado in Orsha. It uses a similar technology, but in this case, it was brick and lime mortar. And it also had, because of the thickness of the material, it gives the insulation, but it had these holes that you can see right here that made hot air to come out and cold air to go in. But it also, there was water that came in, so there was a lot of rain in this area, because of which the water from these got collected into the basement, and then the cold air used to come in, cool the basement with the cold, because of the cold water, and from these water ducts it used to transfer into the houses, or keep cooling up the complete area. Another thing that we are going to talk about in the similar pressure gradient system is the courtyard effect, or the shading, mutual shading. So if any of you are from Rajasthan, or from places where there are, even from Delhi, where there are very narrow streets, there is an effect that these cities have, and Jaipur per se is designed according to the sun angle, and all the old cities designed according. Okay. My voice is echoing. It's okay. I'm good now.
It is
So
fine now.
yes, it's good. So the mutual shading, along with the cornices that are decorated on these walls in the Rajasthan houses and palaces, the decorations in the cornices and the facade not only self-shaded the facade, but also shaded each other because of the width of the street and shading the street itself. This street that was shaded became a cold air zone, became a high pressure zone, as we mentioned. And then inside the house, the situation such happened that the positive wind pressure that was collected outside had strong gush that could move in the courtyard, which was open. And because of the courtyard being open, a lot of heat got accumulated from the complete apartment, from the complete house. And the hot air rises up. The hot air rose up, and all the cold wind and the air that is accumulated in the streets used to go inside the house, cooling up all the rooms around the space and also the courtyard. And another thing that you can add to those spaces is a water body. If it is a hot and dry space in a hot and dry climate, the water body can give an evapotranspiration effect that also helps in cooling up and making the place more humid and moist, which we're going to talk about more. Something that is very evident and coming to New York, I see it way more than back home, is the importance of trees and deciduous trees. So when it is the summertime, deciduous trees are completely flush and they have water, they have complete foliage, because of which, if they're placed alongside the facade of on the south facade or the west facade of a building, they help prevent harsh sunlight to come in. And mostly we place evergreen trees towards the west side, because the west side in India is supposed to be very harsh because of the sunset and because of the heat accumulating throughout the day. On the south side, we usually place deciduous trees, which block the sun rays in the summers, and in the winters, the sun rays go way down, and the deciduous leaves shed down in the winters and letting the winter sun come in and making the house warmer in that case, or any building per se. Another interesting thing that along with natural ventilation that we can talk about is wind pressure. So wind plays a very important role when it comes to buildings, and we've talked about wind cooling down buildings using wind catchers and everything. But what we don't notice so much is how a building that's already constructed has an effect on another building. For instance, if in New York City, where I am from, there are wind tunnel effects that happen because of the high skyscrapers. So, and there is a water body right next, it's an island. So in the island, because of water on three sides and tall skyscrapers, there are streets that become extremely windy. Even more so, what happens is that if you construct a certain building, and the usual wind flow was throughout this area, that certain building becomes a blocking point for that wind. And then the wind redirects its direction according to whatever is stopping it, whatever is letting the wind in. And the wind also creates positive pressure zones and negative pressure zones. And in this instance, for example, when the wind is directly coming into an apartment, to a window, it is a positive pressure zone. However, it is going through this area but never entering this zone. So this becomes a place for negative pressure zones, which accumulates wind currents. And then it can either become a place of warmth, or it can become as a courtyard effect. But if by placing water in this area, it could also catch the wind flow and make the place more develop a microclimate for that place, making it more colder. Another interesting factor that we have here is evapotranspiration that happens because of varytherm walls. So varytherm walls are a concept that can be used in a warm climate as well as a cold climate. In the case of a warm climate, the varytherm walls can be green walls because they help us in creating a variable thermal temperature, as we said, the positive pressure and the negative pressures. When there is solar heat radiation that's hitting the plants or the green wall, there is evapotranspiration that happens throughout this area, making this really extremely warm, and the gap between the window or the facade of the building becomes a warmer space that is a negative pressure zone. And anything inside also starts becoming a negative pressure zone because of these things. And then if there is a wind that comes from outside, there is conduction, and because of the change in the two pressure zones, the wind takes the place of the negative pressure zone that was starting to get created here, cooling out the whole space. A similar concept can be used in a cold climate in the term of a varytherm wall, or it's also called a therm wall that we will see here. In the case of a varytherm wall, there is a concrete wall that has an insulation gap. And this is, and in the insulation gap is merely of cold air. And these gaps, the heat from the sun passes through the glass. It heats up the concrete, and the concrete stores in heat because of the conduction, and also the insulation gap stores a lot of heat, because of which the complete room or the space can start getting heated because of just radiation and convection. And similar situation happens in the therm wall, where the concrete wall in this case is painted black for more effect, for more heat. But what we don't notice here is that there are very few techniques that one can use for a cold climate, because these techniques are not the best. They are used in Leh and Ladakh, but there is a lot of heat loss that happens through these glass panels or glass walls. We do agree that the glass panels have infrared rays that go in and capture heat, causing the greenhouse effect, but it might not be the best case scenario to be used in cold climates, in which cases we need to start thinking about air tightness, and instead of passive architecture, moving towards passive house. So as architects, our goal is to have a design, make sure that there is simulation. The simulation could be through plans, through bioclimatic design, through passive strategies, and that simulation creates a microclimate, which microclimate needs to be analyzed, and then it needs to be sent back into the design process, because it is a loop than a straight process. And microclimate creation needs to be a goal when it comes to a hot or humid climate. And for cold climates, it's also about microclimate creation, but in an opposite manner. So we start with some case studies. This is a building some of you might be familiar with. It's in Pune in India. It's called High Performance Computer Center and CCCR in Pune. This is a high performance building, and because the reason that it's a high performance building is because it is a research laboratory that is open for 24 hours a day. But the design of the building is it's in a hot and humid climate, so it's based on IGBC, and the design is by Madhav Joshi and Associates. The building is the orientation of the building is according to the sun path diagram that some of you might have seen, and we can talk about in detail about this some other time to see that what is the right orientation. It is usually said, and we used to study, that south 20° east is usually in the southern hemisphere. It's the best orientation for your project, but it also depends upon the location and what are the current bioclimatic climatic strategies existing in the current site, and then adopting the sun path. The building is exciting because it has a wind tunnel effect. It has a stack effect that leads the ventilates the whole building, and it also has sunlight coming throughout the all the sides of the buildings. The building is open on the south and has louvers on the west and the east side. However, the most important and interesting segment that this building has is its nighttime operation and its daytime operation. The nighttime operation for the building is such that they have a wind catcher that we saw in the vernacular strategies like the Iranian tower, and the wind catcher gets the warm or cold air in the nighttime, and all the cold air that gets accumulated, it passes through a pipe that is 4 meters down from underground the site, and it is an underground tunnel that brings the air into the building, and in the slabs of the concrete slabs of the building are embedded PEX pipes. So these pipes get all the cold air and release the air into all the rooms in this building. So when it's daytime, the buildings are already cold enough that there is lesser air conditioning required. In the daytime, they also have fresh air natural conditioning that the wind tower draws, but it's already pre-cooled the complete building in the night. But because of the stack effect, the building also keeps getting ventilated because all the air that's warm, it accumulates in this atrium, or we call the courtyard effect that we had earlier, and it gets out from the openings on the terrace. Another interesting feature that they have is these spouts like features. These spout like features are use the wind tunnel effect, or also something we also call as the venturi effect, that the wind goes from these small spaces again into the PEX pipes, and it cools down the building from all directions. And then all the louvers are designed in such a manner that they are at 45-degree angles or 0-degree angles, depending upon the angle of the sun. As I had earlier mentioned, the louvers are at 45-degree angles on the south side to make sure that the right rays come in, and on the south side it's at 0-degree rotation, but at the west side it is at 45-degree rotation along with the east, so that the right rays come in, and the building is shaded throughout the day, but it's also well lit because of the atrium. One of my favorite buildings that is always an exemplary one is CII Godrej in Hyderabad. Why this building is very important is because it's been the building was, when it was first constructed, it was a GRIHA rated building, and most of you might know that GRIHA is the green rating system in India. However, it was never a LEED building. It was never a net zero building per se. However, after 15 years of use, the building got its LEED Platinum and net zero energy platinum rated certification because of just its performance. It is in a hot and dry space, and it is a commercial building which was completed in 2003, which is a big deal. The building is a courtyard building, as you might see, and it's a complete circular space with a terrace garden on the top. And now they have these beautiful solar panels that also make the top of the building. One interesting feature about the building was that, and this is a building that talks about materials a lot, the site was cleared before construction, and all the sites do that, but they usually demolish the site and take all the excavations out, and it never knows where those excavations went away. However, this site, they excavated the land, the soil, the rocks, and the landscape of the site was preserved, and when the project was completed, it was replanted and re-put into the complete site, making it extremely interesting And they use like sustainable materials to even prevent these hexagonal trays that were used to prevent soil erosion and make sure that the soil doesn't lose its elasticity. The building is a courtyard building with green pockets throughout. It has the courtyard effect that we were talking about earlier on. You might see in continuous instances that this building is a complete mixture of a lot of things that are happening in the passive strategies, and they are adopted in a very sensitive and smart manner. We have these open corridors that open up to the courtyard, and then there are terrace gardens as well. The building gets enough sunlight throughout the day, because of which it reduces the pressure on external devices. The wind tower and the cooling tower, in this case, unlike the previous example, this is a different one. It takes the cold air from the wind tower and it goes to the basement of the building. In the basement of the building, there is the air handling unit and the chiller system. All the cold air goes to the air AC system, and it reduces the pressure that it is required for the inlet. The supply air is already cold, so it reduces the pressure that the machinery will use, the HVAC system will use to cool the air and send back into the building. So that has reduced a lot of energy requirements, and it is used for a very few months anyways. Then the building also uses the very famous jalis that we have in India, and not do they only create beautiful screens on the ground, but there are also spaces for the venturi effect that bring in cold air. And when you team it with these plants, the section that used through the jali, the air rainwater seeps in, there's evapotranspiration, and then this water is also used by these plants. But other than that, it is also creates the microclimate effect in the courtyard that we all talked about. And then there are rooftop gardens and rainwater harvesting that is also a part of water conservation and water efficiency use in not just LEED, but also in any building. And this water is used to replant and re-water the gardens used for other purposes. Now we leave India and we go towards Singapore, which is another interesting country. However, we're going to talk about a building that is made by an Indian architecture firm that is called Siri Architects. So Siri Architects did the School of Design and Environment at National University of Singapore, and this project is of their first net zero building. It was designed to be net zero, but it is positive energy now. That means that it is not only not consuming any electricity or energy, but it is giving back to the grid, back to the school. And it is also zero energy certification and gold building. The building is academic construction for sure. And the most interesting part about this building is the bioclimatic setting that it sits in. The bioclimatic setting is the lush, beautiful campus of Singapore, National University of Singapore, that I visited a few years ago, and it has grown ever since. And then the building is completely it's completely ventilated with open windows and louvers on the east and west side, which not only aid to shading but also to ventilation. And then the building also has 70% of the building is without air conditioning. There's only 30% of the building that has air conditioning, but they also use fans, which you'll see in a few pictures later. Another interesting part about the facade is that since it's a design and architecture school, they have this facade that is at different angles, but it is also 1:1 at 1:1 scale. So it is like a design prototype, which is like it is an active facade. Students can take the facade pieces out, understand the joinery together, and fix it back again. So this is the landscape is not only used for purification, but since Singapore is a very humid country, it helps in a creation for microclimate along with the water bodies that pass through the complete stream of NUS. And then, as mentioned, instead of having completely air conditioned space, some of the space are ventilated and they have fans to support cooling, which is very different from a lot of countries, a lot of Western countries, and even Singapore, where all the places are completely air conditioned. So having no air conditioners in most of the spaces is very different. And then standing inside the building, in this you can see how the microclimate is created not just outside the building, but because of the ventilation and landscape, it's also created inside the building. And then on this space, we move on to a completely different space, that is Arizona in the United States. It's one of the warmest states in US, and it has a lot of its issues this month. This year, it had the worst summer with 47 degrees, 45 plus degree temperatures for the whole month, which is unusual for a country like United States. So this is a project that is done by my office, and I wanted to talk about the Western way of introducing sustainability, because it is extremely different from how countries, Southeast Asian countries like India and Singapore work. In the US, it's not only about creating a microclimate, but it is also about certifications. It is also about understanding how the design needs to be beautiful in a very different manner. There needs to be skyscrapers even in the midst of a desert, and that's what this building is trying to signify. However, the building also has some interesting technology that we might as in that we are still grappling with in India. We're trying to learn. A lot of our firms are now doing complete solar gain and heat analysis, temperature analysis, but the way wind has been determined in these countries, it's exemplary and something that we should learn from as well. So the building has solar heat. The building canopies are designed in a manner that they come out. It not only makes the structure structure come out of the building, but also provides shade to the big canopy of the place. And it also becomes, these bridges become a place of shade, but also connectivity between the two blocks of the building. So the building in the courtyard that the building has, it also becomes a place for courtyard effect. And unlike a lot of US buildings that are completely glass, yes, people love glass in this country a lot, and you're going to see a lot of glass buildings. But the courtyards are, for a change, they're open, they are ventilated, you can move around. There are these screens that not only become place to look at signages, but also are screens that allow wind to travel across the place. And this is one of the project that is exemplary for Ennead architects, because after its completion, 5 years, even 5 years after it, it's become a safe haven for a lot of people, because in the peak summers, they've never had any complaints. They move in, the building is becoming now net zero per se, and its performance has just been increasing compared to other colleges that are in Arizona State University. As already mentioned, the center bridges create these sails, provide shelter from the sun, but also let the wind come in, because it's the courtyard. So it also creates that courtyard effect, and which leads to the terrace garden. So all the warm air that rises up goes to this terrace garden, which eventually cools it all down. And then with time, the building is now LEED Gold. It is a high efficiency building, high performance building. It all has these chilled beams that are technology, mechanical technology that help in cooling the building and reducing the energy consumption, because the chill beams store a lot of cold air and reduce the amount of energy it would require. Then the facade is self-shading, and there's highly sustainable materials that are used, that are something I'll be talking about in terms of LEED Gold and LEED being a marker for that space. So on a conclusion, the building has used 90% of the recycled structural steel. It uses 37% lesser energy than a similar type of building, and it is as clean as possible. It also contributes to well laws, and it is an environmental friendly building. However, something that one might observe in the previous examples versus the examples in the US is the way that architecture and sustainability is termed in this country. In the Western countries, sustainability is not lesser about providing comfort through ventilation and not just like internal landscape or courtyards, but it is more about providing human comfort by air conditioning, because air tightness is very important to the people, and their comfort conditions are based on how well the building performs in terms of natural ventilation and heating. So the passive techniques that these buildings in the Western countries use are all used to reduce the load that is required by an HVAC system to cool up the buildings, and they are extremely cold. And that is something that I always talk to people around here, that we don't need air conditioners so often. Sometimes we can put up a sweater as well. So the next thing that I want to talk about is this is all the things that we've been talking about: a warm climate, that is a super warm climate. However, another thing is passive house. So I'm gonna move very faster now. And passive house is a space where it's a certification, but we talk about air tightness and the building envelope, like locking the building, heating up, locking everything, so there's no air loss. We've been talking about passive solar right now with street widths and solar movements, but passive house talks about how compact the building is, how much of a radiation are you letting the sun to come in, is the enclosure tight enough, how low energy can you make the air conditioning system to be so that there are no leakages, is the building energy efficient, all the equipment that you're using in the building, is it correct, is it as per standard? And then there's also user friendliness, that if you can control the building. So bringing in an example of passive house building comes to New York City, which is an extremely cold place. We have winters for 6 months. So this is a Cornell Tech building. It is also a it is also a glass building, but it's lesser glass than the previous one per se. And if you observe in this huge building that is in a beautiful setting, look at the sizes of the way the building has been oriented, the way the building has been shaped to reduce any of the solar radiations that comes in. It is one of the tallest passive house certified building. Passive house also requires buildings to be electrical completely, so that if the building becomes 100% electrical and we can clean up the grid, then if a clean grid fuels a clean building, and it is a LEED Platinum building by Handel Architects. New York City in itself has very strong energy code, and New York City has said that by 2040, all buildings in New York City need to be 100% electric buildings. So the building has a solar angle of south 20 degree east, like I was explaining earlier, if you see right now. And then the building has a very compact shape. There is minimal exposure of the building to the sun. the building, the compact shape not only ensures that there is lesser window space outside, but it also makes sure that more and more spaces are indoor rather than outward looking. And then the building is completely enclosed. So as you saw earlier in the building, there is an enclosure that is in the terms of a complete facade grills that move around the building made of aluminum. And this complete facade also allows to wrap up the building and make it more tightened. And then there is central ventilation, which happens throughout this building. And then there is the HVAC system that is extremely tight. So this is all about passive house. However, as architects, we often get confused as to how to start, where to start sustainability from. Should we study? Should we research? Should we design or construct? But it is this where it all lies in. It is in social sustainability, environmental sustainability, and economic sustainability. So you, as an architect, sit down in one place, understand that, oh, I need to solve natural ventilation potential, or I need to solve the utility bill. Stand in one place and then decide what are the tools that you need. So skimming through some of them, we have AI tools that now can measure all these things that are mentioned here, from energy modeling to shadows. We also have ladybug tools like Honeybee and Ladybug in Grasshopper that can help us do climate visualization and analysis. This is a daylight analytical diagram of how windows can impact a building, and how what is the useful daylight like and what is the non-useful daylight like, specifically in terms of laboratories and hospitals. And then we have these certification systems, that is LEED, Well, Living Building Challenge. And as someone who's in this process right now, I believe that as someone who doesn't understand sustainability as all, if you're in the professional environment, starting with LEED, Well, and these certifications can help educate you in the right process of sustainability. And if you just follow a Well or LEED certification for a project, you can understand that how these certifications are also helping in understanding material sciences and water efficiency and other wellness criteria for the building as a starting marker. And then you can take your steps back towards design. And I believe that I'm also learning with all of you. I'm young in my career right now, trying to learn as much as I can. Any of you who feel that you are passionate about this topic and want to stop the detrimental effect that environment has, and want to take a step towards climate change, because it's changing and we are also changing every day. So we are here to learn, make our building environments sustainable, healthy, and cleaner, and so that everyone can live here and breathe nice air. And I think it's all about starting, and I'm starting today. I started yesterday, I'm starting today, and I will be starting tomorrow. So it's just a process. Thank you.
What an insight, Sana. Much more than what we were expecting. An excellent presentation. Thank you so much. Uh, our director, Sir Professor Vivek Sabarwalji, is also with us. So I would like to ask Sir to say a few words over the presentation. Over to you, Sir.
Thank you, Sana. I think this has been a splendid presentation, very lucid. And though I joined late, but I thoroughly enjoyed, and I'm sure the students would have enjoyed. And let me congratulate you. And it's a great pleasure to have you as a speaker here. And I think what was wonderful about the presentation was that in the manner in which you explained, the wide spectrum of projects that you showcase to the students in the projects which are in India and projects which are in Singapore or US, and at least the projects which are in India, which are accessible to the students. So now it will give them a push to go and visit those buildings, because the topic is such that it impacts everyone across the world. So there's no one who can say that they can do without sustainable architecture, or for climate change, everyone has a responsible role to play. And it's a great credit to you and your firm, which is working towards sustainable design. And I'm sure this presentation will also excite the students and propel them that whenever they do a design project, they should keep the sustainability and in mind, and all the factors that you mentioned. And as an institute, we have been very passionate about climate change and sustainability. So every year we do a major event. We try and, even though it is there in our curriculum, but we try and, from our end, bring in those small exercises and bring in a lot of people to give lectures, so that this is an ongoing effort. It doesn't end with just one special lecture or one exposure. It has to be drilled into everyone's mind that this is the future. And as a young generation, all the students will turn into architects in a couple of years. They have a huge responsibility towards society. So really, thank you so much for giving such a splendid presentation. And I believe there are a few questions. So I'll request Rajiv, ma'am, if you have some time, that he will, put up those questions, and if you could respond to them.
Yes, thank you
Uh,
so much, sir. It's great to be here.
and it
And
would be great if you, whenever you are visiting India, we would like to host you and invite you to our campus. Yes.
sure. Thank you so much. Thank you for the invitation.
Yes, Sanah, can you see the questions?
Yes, let me. Um, okay. So I see a question about the source which states which suitable building orientation can be good for Indian climate. One answer to this question is that Indian climate is different throughout the whole country. So, first, as I mentioned in the Köppen climate, look at the Köppen climate situation for the state in India that you're looking for. And then there is a very thick book that we started to study. It has this beautiful the diagram that I was showing you of the globe that shows this the solar altitude and the solar azimuth angle. That book is a very good guide. If I can share the link with Rajiv sir and he can send forward the students. It's called sustainable. It's a green book called Sustainable Architecture. That book is a good guide for students to understand how the orientation of the building can be placed according to the solar azimuth angle. So that is a completely different lecture in itself, but that's a start for you to start reading that book. And if you have any doubts, we can always answer questions according to that. So, Siddhi asks how spout can be used to cool the building. So, if you saw in that building, the HPCC building, that spout is basically an opening to the PEX pipe that is connected in the building. So, that spout collects, it's in different directions and it brings in air from different directions from outside and becomes a smaller gap, a hole to let wind that's gushing inside the building. From the smaller opening, it goes into the larger PEX pipes, and those PEX pipes, when you become as air conditioning pipes, like air conditioning ducts, and open up in the environment, in the complete rooms through the floors. So all the PEX pipes are in the concrete slabs, and then they open up in the floors. If I had a screen, I could draw. But uh, can I draw here? Maybe. I don't know. Do we have time to draw? Okay. Hmm. Maybe I can. Okay, I can do that at the end. Remind me. Okay, so 100% electrical building. So 100% electrical building means that it requires no energy from any heating or cooling that's happening. No fossil fuel obviously is not being used. No carbon is being used. All the mechanical systems, all they don't use any carbon in the building. So when the building becomes 100% electrical, all its processes are used by electricity. If you imagine what are the different processes any building will use, it can be from a stove, a cooking stove. So instead of turning using a gas stove, it's an electrical stove. From using air conditioning that is from gas or from carbon, it is turns into using electrical HVAC systems. And all the things, since they are being powered from one grid, so if you clean up the grid, that means the source of the electricity, that is the government electricity, if you clean up, make it clean and electrical, if you have zero electricity, it's from like sun, solar power or anything, then when the grid becomes clean, the whole building and the grid is now green, completely green. And then there's very few carbon that's being used. And that's the process that New York City is adopting. If anyone's interested, they can look at Local Law 97. And what is Local Law 97 in New York City? It started with Local Law 32, which was reducing energy emissions in New York City buildings by 40%. And then it moved to Local Law 86, and they fine if the building doesn't reduce carbon emissions and energy emissions by this percent by this year, you are going to be fined this much every year. And it's not small, it's thousands of dollars. So look at Local Law 97 and you'll understand more. What is the most challenging aspect of passive house construction? So, like I said, passive house is very different from passive solar. Passive house construction is extremely challenging because you have to make sure that there is no leakage. So it's more towards, lesser towards just designing, but more towards mechanical as well. So here the structure engineers, the mechanical engineers play a very important role, and to ensure that the blower door tests are done in. And then, as I was earlier mentioning, a lot of New York City buildings are glass buildings. So how do you make passive house work in glass buildings where can be, if there's even a smaller minor opening, there is a loss of complete air conditioning and heat in a building. So there's a lot of challenges that come with passive house construction, and passive house certification is a way for people who want to become passive house constructing people. Making a building completely 100% electric is also impossible, because right now, even in New York, there are maybe 2 3 buildings that are in US are that are commercial buildings that are 100% electrical and passive house. But passive house has till now only been possible in majority of residential buildings. So it is a challenge that is acceptable, and we are moving towards that.
Okay, so now we are running short of time. So let's, I also got a number of questions. I'll put some of them to you.
Right.
One is there, what strategies can we provide in our building for ergonomic sub-environment?
Ergonomic.
Sub-environment. I think there is something missing in it. Okay, anyway, let's take this one. In one of the case study, I think of Pune, where pipes were laid for walled air in basement chillers and AHU unit. Then still energy is consumed in running AHU units. How can it be energy efficient? Isn't it contradictory?
It's not really contradictory. So in the Pune building, as you were saying, there is energy that's being used in energy that's being used in the HVAC system, because obviously that is important to maintain the temperature system. But if the wind comes from the wind towers, the inlet is cold air, then there is lesser energy that's being used by the unit to cool the air. And then the energy that's being used is coming from solar power that is on top of the building. The building's already cold, then there is cold air inlet that is reducing the requirement of energy, and then the energy clean from solar power. So, anyways, that's why the building becomes net zero, because it doesn't use any electricity from the grid. If that
Next
answers.
is the next is they want your views on this, that about how much the neighboring buildings which is not designed to respond the climate can affect or add energy load on the building we design.
So any neighboring buildings that are along your building do have an effect. It can be a positive or a negative effect. If there is a very tall building next to your building, it can hamper sunlight coming in. But in case of those situations, as we were talking about the climatic study, so in those cases, we need to do microclimatic study of that situation and then assess it case to case, that what are the things that we can adopt because of the building next door. Obviously we cannot do anything to better it, but we can better our side as well. So it depends upon case to case. I can't really answer without knowing a situation actually.
Okay, the last question, we can take this. In the metro cities where we don't have enough space for natural ventilation, they want your suggestions for some days out.
So if everyone knows, I'm living in New York City since the last 1.5, 2 years, and I think that New York City is the biggest example of how there is no space in the building. The buildings are, it's a smaller city than Delhi, New Delhi, which is anyways a small city, and then it is high rise. So how the density issues were catered by going high rise, and in case of ventilation, there is lesser natural ventilation on the upper floors because of the wind that comes in, and more ventilation because of mechanical ways. So how being 100%, they are solving problems that they created earlier. So since they didn't have natural ventilation, they had ventilation inlets. So all buildings are air conditioned and naturally ventilated by mechanical means, and that mechanical system is electric. So now that becoming electric cleans up the grid. And when the grid becomes clean, the building hence helps in becoming clean. But everything on the ground floor and on the top four floors are tried to have open windows and have more natural ventilation, specifically on the podium levels.
Okay, thank you. I hope most of the questions are answered. Okay, thank you so much, Sana,
Yeah, and
for
I
a
think,
wonderful.
Sanah, if I may request that I'm sure the questions are still pouring in, but to be fair to those whom we've not been able to ask questions, can we send some questions through email to you, and maybe
Yes, yes,
you can answer them later on? Yeah.
yes, that would be completely
Yeah.
fine with me.
Thank you so
I
much for joining and sparing your time to be with
Oh,
us.
and I would also want to say that any of the people who feel that they are very passionate about this, want to have a profession in this, or would like to help in any way to preserve the environment and the sustainability situation that we have right now, can write to me, have my email or message me on LinkedIn. Anything is okay, because I have had people who have been passionate enough to talk about my advocacy of this topic with me and are working with me to make take me to another level. And I would want to give back to my country and help any of the students who would want to take the same path.
Thank you so much.
With this, I would like to thank everyone, all my colleagues, all the faculty members, directors, sir, who spread the birds among other colleges as well. We received more than 200 registrations from other colleges as well. A big Thanks to everyone who put in efforts to make this possible. I'd also like to thank all the supporting staff to help us out for this. And with this, we are closing it. Thank you, everyone, once again. Thank you.
Thank
Thank
you,
you so
ma'am.
Thank you so much, sir. Thank you, everyone. Thank you.